Uh, Good morning to my class. Welcome. Today's topic is structure isomerism, type of reaction, hazard, risk. This type reaction. Okay, structural isomerism. Do you know what is structural isomerism?
Yes, sir.
What if the molecular formula
They have the same molecular formula but different structures.
these are called the compound which have same molecular formulas but different structure formula, they are called structural isomers, or this phenomenon is called structural isomerism. Okay, structural isomerism, maybe I have given definition: compounds with the same molecular formula but different structural formulae, they are called structural isomers, and this phenomenon is called structural isomerism. Structural isomerism, three types mainly for you. Here, structural isomerism, chain isomerism. Chain isomer have same molecular formula but differ in their carbon chains. This is straight normal chains. This is branch chains. You can check this molecular formula same but different structure formula. Butane and 2-methyl propane is chain isomer each other. Functional isomerism, functional group isomer have same molecular formula but different functional group. Here alcohol functional group, here ether functional group. Okay, position isomerism have same molecular formula but define the position of functional group or double bond or triple bond in on a carbon chain. Look, butane, 1 butane and 2 butane. 1 butane double bond position is 1, 2 butane double bond position is 2. Okay, I have drawn these things last class. I not take this. How to draw? If the molecular formula given, how many structure formula can be drawn? I shown in last class. Have you seen maybe? This thing I have discussed already. A type of reactions. It is actually in the type of reaction here will be discussed. Organic compounds type of reaction, especially not all type of reaction, there are many types of reaction. Here we will discuss especially for organic compounds type of reactions. Okay, this the type reaction: addition reaction, substitution reaction, oxidation reaction, reduction reaction, polymerization reaction, homolytic fission, heterolytic fission. Okay, some things, some free radicals and electrophile. This definition we learn. What is free radical, electrophile? Okay, the type of reaction is addition reaction, reaction in which two molecules combines to form one molecule, and substitution reaction in which one atom or group of atom is replaced by another atom or group of atom. Oxidation reaction in which substance gains oxygen or loss hydrogen. This is vice versa. Gain oxygen means oxidation, or loss hydrogen, oxidation. Reaction is vice versa, oxidation. Here reaction in which substance loss oxygen or gain hydrogens. Okay, polymerization reaction in which a large number of small molecules react together to form a one very big large molecule. Okay, homolytic fission, the breaking of a covalent bond where each of the bonding electrons live with one species forming a free radical. Here homolytic fission, we know each covalent bond contains 2 electrons. This each electron will move towards 2 species, will take same 2 like chlorine double bond. Here 2 chlorine content. Here if homolytic fission occur in this bond, 2 electron come, 1 electron, another electron come, another chlorine. This is for homolytic fission. A heterolytic fission, the breaking of a covalent bond so that both bonding electrons are taken by one atom. One atom is taken another atom there is no electron. So one atom, two electron take one atom, or another atom nothing. So taking two atom containing atom become negative charge, and no electron containing atom become positive charge in a heterolytic fission. So heterolytic fission form anion cation. Homolytic fission form radicals, free radicals. Okay, what is free radical? A species that contain an unpaired electron, like single electron contain. Single electron containing any chemical species is called free radical. Okay, what is electrophile? Electrophile is a chemical species that is attached to the region of high electron density region. This is the addition reaction. Here two reactant species combine together to form a single product. Two reactant combine form a product. Here bromine and ethene combine form this 1,2-dibromoethane. Substitution reaction in which one atom or group of atom is replaced by another atom or group of atom. Like here OH replace bromine and take this position, and bromine come out. In this reaction, OH group is taken the place or substituted the bromine atom. OH replace this and take this position. This is the substitution reaction. Like football match, one player out and another player enter this position. Substituted player, like now oxidation reaction. In oxidation reaction, you know, gain of oxygen. One organic compound is oxidized usually by an inorganic reagent. This means that organic compound can either lose hydrogen or gain oxygen. There is example here. This compound gain oxygen or loss hydrogen. Here ethanol, and this is oxidizing agent. We write oxidizing agent in third bracket. This is diamond oxygen. So here it becomes this compound ethanol become in water. Look this compound here, hydrogen is 6 and 1. So hydrogen is total 6 hydrogen, 5 hydrogen and 1, 6 hydrogen are here, 4 hydrogen. So what happened here? Is it gain of oxygen or loss of hydrogen? What happened? Hello? Hello student, what happened here? Either gain of oxygen is occurred or loss of hydrogen occurs, or loss of hydrogen or gain of hydrogen occurred or loss of hydrogen occurred. What has happened here? Is this compound?
Loss of hydrogen.
No, hydrogen here is a 1 and hydrogen is 1, same hydrogen.
Gain of oxygen.
Oxygen is same. Look, oxygen 1, oxygen 1, oxygen.
And loss.
Here hydrogen is 5 and 1, 6 hydrogen. Now hydrogen here 3 and 1, 4 hydrogen. So what happened? Here 6 hydrogen. Here now 4 hydrogen. What happened? I given shown clue. Gain of oxygen or loss of hydrogen? What happened? Or which thing happened? Okay, I am this here is a 6 hydrogen in this compound ethanol. Now 4 hydrogen in ethanol. So loss of hydrogen occur. So loss of hydrogen or gain of oxygen means oxidation. So this reaction is oxidation. Okay, we write this symbol, diamond symbol, in oxidizing agent. You don't need to write O2. If you would be incorrect, you should write diamond oxygen. If you write O2, it would be incorrect. In this case, It suggests that oxidizing agent is molecular oxygen from air. If you write O2, or if you write diamond oxygen, it suggests this oxygen comes from inorganic reagent. Okay, oxidant. So you should write oxygen in third bracket. Don't write O2. If you write O2, that it suggests it come from, this oxygen come from air, but this oxygen is not come from air, it come from inorganic reagent. Okay, reduction reaction in which organic compound is reduced sometimes by hydrogen gas and catalyst, sometimes by an inorganic reagent. This means that organic compounds can either gain hydrogen or lose oxygen. This is okay. Here what happened? Gain of hydrogen occur. So what is this? What type of reaction this is? Okay, this reaction is reduction. Why? This is ethene now become ethane. This reaction is reduction reaction. Why this reaction is reduction reaction? Hello, student, are you listening me? Hello, student, are you listening me? This reaction, what is the type of this reaction? This is ethene become now ethane. I told this compound. Okay, what type reaction?
Reduction.
Why this reaction is reduction?
Because there's a great gain of hydrogen.
Gain of hydrogen. Okay, here was 4 hydrogen, now it's become 6 hydrogen. So gain of hydrogen.
Six hydrogen.
Okay, reduction reaction. Now polymerization reaction, you know, reaction in which large number of small molecules react together to form a very large molecule is called polymerization reaction. Here a lot of small molecules join together form a big molecules. This is a polymerization reaction. A familiar example of this type of reaction is the polymerization of ethene to polyethene. Okay, you know this polymerization reaction. Okay, now I am showing this polymerization here. One polymerization reaction. Like ethene, 2 ethene join together. 2 ethene molecule join together. 2 ethene join together. Okay, so what will be this compound? So here is a okay, this is one ethene when become polymer this way, and this is another ethene when it form polymer from this way. Okay, this way we can write, because here 2 atom join, 2 molecule joins. This is 1 molecule, for this one is for this 1 molecule. Here is another 1 molecule, 2 molecules. this the second molecule, this. Okay, these two molecule joining we can write here this way. Don't need to write these things many times. You write here these things and give a bracket and give here two molecule join together. Okay, when two molecule join together, you can write this way. So you two molecules join together to form this way. You can write its polymerization form. If three molecules join together, you can write here 3, and you also can write here 3. Okay, if many molecules join together, you can write here n, you can write here n. Okay, this is the polymerization reaction. Okay, polymerization reaction done. Here at least in a polymerization reaction, at least 4,000 molecules join together from at least more thousand molecules join together from a molecules. So there is, so it is not able to write this way. So we write this way. I shown how to write. You write n and give this n. Okay, bond breaking in organic reaction. Organic compounds contain covalent bonds. For example, between two carbon atoms, or a carbon atom and a hydrogen atom, or a carbon atom and halogen atom. So organic compound contains covalent bonds, sharing bonds, sharing a pair of electrons. This covalent bond contain. This covalent bond form in either between two carbon atoms, or between a carbon atom and a hydrogen atom, or a carbon atom and a halogen atom. Okay, there are two different way for covalent bonds to break. This breaking, two types of bond breaking is homolytic fission and heterolytic fission. Where is covalent bond are present? Their covalent bond are present in maybe a carbon-carbon covalent bond, or carbon-hydrogen covalent bond, or carbon-halogen covalent bond. This type here covalent bond are present here. Here is carbon-chlorine. Here carbon-carbon covalent bond. This type bond is present. Okay. Now here this covalent bond are present here. Carbon between carbon and hydrogen, or carbon and carbon, or carbon and halogens. The halogens like fluorine, chlorine, bromine, iodine. Yeah, time is very dull. Now homolytic fission. Homolytic fission, like many other scientific terms, homolytic comes from Greek homo, indicates same. Lytic indicates splitting. Splitting means breaking. In homolytic fission, the shared pair of electrons in the covalent bond divide equally between two atoms. This can be shown. This shared pair of electrons divide equally between two atoms. This atom will take one electrons. This atom take one electrons. These two electrons in a bond. So they form this unpaired electrons. This is called free radicals. Each product species take one of the electrons from the covalent bond. These species are called free radicals. These two are called free radicals. Each free radical has an unpaired electron and is uncharged. Homolytic fission usually occurs when two atoms bonded together are identical. When two atoms are identical, like carbon-carbon, carbon, chlorine, chlorine, or they have similar electronegativities, electronegativities, then a homolytic fission occurs. When two atoms are identical, like carbon-carbon or chlorine-chlorine, or have similar electronegativities, these types atoms show homolytic fissions. Okay, heterolytic fission. Heterolytic is another term from Greek hetero, indicate different, and lytic indicate splitting. In heterolytic fission, both electrons of the shared pair in the covalent bond are kept by one of the atoms. This can be shown here. Two electrons kept by one of the atoms. This atom kept two electrons, and another is no electrons. The left product species keep both of the electrons from the covalent bond. This species is negative ion. The right hand product species don't keep either of the electrons from the covalent bond. This species is a positive ion. So heterolytic fission form positive ion, negative ion, and homolytic fission form free radicals. Okay, what are the two types of bond breaking that can occur, and what are the product of each type? Say, what are the two types of bond breaking that can occur, and what are the product of each type? Are you listening me? Now I am asking question you. What are the two types of bond breaking that can occur, and what are the product of each type? Hello. Hello student, unmute and give my question answer. Again you are maybe facing problem. Are you facing problem in base? Of each types. What are the two types of bond breaking that can occur, and what are the product of each type? Okay, this is homolytic and heterolytic. Their product produces free radicals. Heterolytic produces ions. And free radicals, what is free radicals? An atom or molecule that bear an unpaired electrons and is extremely reactive and capable of engaging in rapid chain reaction that destabilize other molecules and generate more free radicals. Okay, it is atom or molecule that bear unpaired electrons. It is extremely reactive and capable engaging rapid chain reaction that destabilize other molecules and generate many more free radicals. Okay, electrophile is a chemical species which is like a negative region of high electron density region like. So electrophiles are positive species. They like negative. Electrophile means electron like. Phile means like. They like electron. They like negative chemical species. So it must be positive chemical species. A species that attack the region of high species electron density. They are called electrophile. Like positive ion, positive H plus hydrogen ion. Like CH3 plus, they are electrophiles.